Hey everyone, today we're going to take a look at the 2025 HSC Maths Advanced paper, specifically taking a look at section 1 of the paper, which is the multiple choice section. So let's get into it. Question 1 says the probability distribution table for a discrete random variable x is shown. What's the value of the probability that x equals 3? So what we should know is that the sum of all these probabilities, so x equals 1 plus the probability that x equals 2 plus the probability that x equals 3, the sum of all of them should be equal to 1. And so that means 0.4 plus 0.2 plus that probability that x equals 3 is equal to 1. 0.6 plus p x equals 3 equals 1. And then we solve it like an equation. And so we get our answer as 0.4, so B. Question 2 says which graph could represent y equals 4 to the power of x? So y equals 4 to the power of x should indicate that it's going to be an exponential function, which means that it leans itself to either A or B. And to decide which one of A or B it actually is, we need to realize that 4 to the power of x is an increasing function. So as x increases, y also increases, and that's going to be A. If the answer was B, the equation of the line would be something like y equals negative 4 to the power of x. Question 3 says what is the domain of the function y equals square root of 6 minus x squared? What we need to realize to figure out the domain is that 6 minus x squared needs to be greater than or equal to 0. Now, why is that? That's because it is within a square root. So a square root can't be negative, but it can be 0, or it can be greater than 0. And so that's why we put this restriction here. And we solve for this. So 6 is greater than or equal to x squared. We can just flip that around. And to solve this now, we're going to get x is less than or equal to the square root of 6. But we also have a negative case. And in the negative case, we flip the inequality. So negative root 6. So x is greater than or equal to negative root 6. So if we combine these two ranges, we get a combined range, or a combined domain, I should say, that x is greater than or equal to negative root 6. But less than or equal to positive root 6, which is also going to be D. And that's because these square brackets indicate that it's that the inequality is also equal to. Question 4 says, which of the following best represents the graph of y equals minus 5x outside of x minus 2 outside of 3 minus x? So the first thing that I would do is work out what the x-intercepts are, and that is when y equals 0. So if we set y equals 0 here, we get three cases. We get minus 5x equals 0, we get x minus 2 equals 0, and we get 3 minus x equals 0. So what we have here now is we have three x-intercepts. We have x equals 0 if we just follow and solve each of the equations. So 0, 2, and 3. So if we assume that the x-intercepts are 0, 2, and 3, it can be A because we have those intercepts. It can't be B because we intercept at minus 3, which is not an x-intercept. It could be C because we intercept at 0, 2, and 3. And for the same reason why it can't be B, it also can't be D because we have an intercept at minus 3, which we have just shown that minus 3 is not an x-intercept. So to determine whether it's going to be A or B, we need to essentially determine whether it's increasing or a decreasing function. And that's going to be determined by whether the number up front of the x cubed is positive or negative. If it's positive, the answer is going to be C, as we're increasing. And if it's negative, the answer is going to be A, because we're decreasing. So let me just rewrite the equation here. Now I know it's going to be an x cubed because that is because we've got 3 x's here, 1, 2, 3, and so this function is going to be a cubic function. And to determine whether it's a positive or a negative number in front, we just need to look at the coefficients in front of each of the x's. So we've got a -5, we've got a +1 here that we actually don't see, but it's there, and we've got a -1. So if we take -5 and then we're to times that by +1 and then times that by -1, we get +5. So that means the coefficient in front of our x cubed is going to be a positive number, specifically +5. And that means the answer is C, because we then have an increasing function. Question 5 says, what is the integral of 1 over the square root of x plus 5? To work this out, we need to take it step by step. So we need to realize that a square root is the same as raising something to the power of a half. So the square root of x plus 5 is the same as x plus 5 raised to the power of a half. Now this is on the denominator. And so if we want to bring this to the numerator now, to be able to integrate, we then have this, which is the power of a -half. So to bring it to the numerator, we essentially keep the magnitude the same. So the half still stays there, but we turn it into a negative power. And to integrate this, we just follow normal integral rules, where we raise the power by 1, so x plus 5 to the power of a positive half, because -1/2 plus 1 is a half over a half, and it's an indefinite integral, so we plus c, and this just simplifies to 2 outside of x plus 5 to the power of a half plus c, and we should know now that x plus 5 raised to the power of a half is the same as the square root of x plus 5, so we have 2 square root x plus 5 plus c, and that's very clearly B. Question 6 says the graph of y equals f of x is shown, and it gives us the graph over here. And the question is, which of the following is the graph of y equals minus f of minus x? So we've got two functions or two transformations that are happening here. F of minus x, which is essentially a transformation or a reflection rather around the y-axis. And we've got the minus here, the minus outside of the function, minus f, which is a reflection around the x-axis. Okay? So what the first step to figuring this out is we are going to just take each transformation one by one. So f of minus x is a reflection around the y-axis, and that's going to look like this function here. So what we can see is that the asymptote of -2 is now a +2, and essentially the shape of the graph has been flipped around that y-axis. So yeah, we essentially get A. And this isn't the answer of the question though, because we have this additional transformation where the minus is out the front of that whole function. So now if we focus on this chart, this graph, we are now applying a minus in front of all of it. And that means that we have a reflection around the x-axis. And that is going to lean itself to C. So we can see that C is just a reflection of A across that x-axis. We can see that the asymptote of 1 now turns into an asymptote of -1, and that y-intercept of +3 turns into a y-intercept of -3. Question 7 says, a 10-sided die has faces numbered 1 to 10. The die is constructed so that the probability of obtaining the number 1 is greater than the probability of obtaining any of the other numbers. Numbers 2 to 10 are equally likely to occur. When the die is rolled 153 times, a 1 is obtained 72 times. By using relative frequency of rolling a 1, which of the following is the best estimate for the probability of rolling a 10? Okay, few layers to this question, but I would say it's relatively simple. So we know that we have probability of 1, we have a probability of 2, and so on all the way to a probability of 10. Now we know that by this line here, the probability of 2 is equal to the probability of getting a 3, which is also equal to the probability of getting a 10. So all the numbers 2 through to 10 have the same probability, and there are 9 in total. Okay, that's very important. So 9 equal probabilities. Now the probability of 1 though, using the relative frequency, is going to use this data here. So it was obtained 72 times out of a total 153. And this simplifies to 8/17, which means that the probability of everything but 1, the probability of not getting a 1, is 1 minus 8/17, which is 9/17. And we know that this 9/17 is shared equally by 9 different probabilities. So the probability of rolling a 10, that one individual occurrence, is essentially 9/17 divided by 9, which is equal to 1/17, and that is A. Question 8 says the minimum daily temperature in degrees of a town each year follows a normal distribution with its mean equal to its standard deviation. This is important information here. The minimum daily temperature was recorded over 1 year. What percentage of the recorded minimum daily temperatures was above 0 degrees? Okay, so using information given in the question, so the answers that we have available, we can see that they're all percentages. And we should recognize that these percentages are very familiar. And they're familiar in the sense that we should recognize that we need to use z-scores to figure this question out. So we should know that the z-score of a result is equal to its actual score x minus x bar, which is the mean or the average, divided by the standard deviation. Now the question tells us that the mean is equal to the standard deviation. So in other words, x bar is equal to the standard deviation. So we can really transform this into saying something like this. And if I wanted the z-score for 0 degrees, well, we would just replace an x with a 0. And if we simplify this, we end up getting -1. Now we want the percentage of daily temperatures above 0 degrees. So essentially we need the probability that the z-score is greater than or equal to -1 because it's above that z-score of -1. Now we should be able to figure this out pretty easily now. Oops, that's not a great normal distribution. So if I just graph a normal distribution here, oops, and we have -1 here and +1, we should know that the area between these two is 68%. Okay, so 68%. And that means if we halve it, that means we have 32% for each half. So this half here is 32%. And it's above -1. So that means we're also including this whole half of the area, which we should then also know is 50%. So to calculate the area, we take 32%, add it to 50%. Sorry, not 32%, 34%. It's my bad. And that gets us to 84%, which is our answer. Question 9 says the diagram shows the graph of y equals f dash of x. So this graph here is our gradient function because f dash of x is the gradient function of f of x. And then we have some more information saying given f of 1 equals 6, which interval includes the best estimate of f of 1.1? So the first thing that we're going to see here is, well, what happens when x equals 1 at the for the gradient function? So when x equals 1, we see that the y coordinate, or at least the gradient function, is equal to 2, which means because f of 1 equals 2, 2 is greater than 0, and therefore it's increasing at x equals 1. So because the graph is increasing, that means the value of f of 1.1 is going to be larger than the 6 because we're increasing now. That immediately rules out C and D because those intervals are less than 6. Now, to determine which of A or B is the correct answer, that's a little bit more tricky. Okay, so what I'm going to do here is work out the gradient, the equation of the tangent at x equals 1. So the gradient, the equation of the tangent, so the equation of the line is y minus y1 equals m outside of x minus x1. Now at the point 1, 6, we have a gradient of 2. So that's going to be the gradient of the tangent. So we have y minus 6 equals 2 outside of x minus 1. Y minus 6 equals 2x minus 2. And that gets us the equation of the tangent at x equals 1 being y equals 2x plus 4. Now remember, this isn't of the gradient function here. This is the tangent to x equals 1 on the original function, f of x. Now, okay, what do we do here? So now we plug in the value that x equals 1.1. So at x equals 1.1, the y value of this tangent, 2 outside of 1.1 plus 4, equals 6.2. So it's equal to 6.2, which is a very significant number in terms of, I guess, distinguishing between A or B. So it marks an upper bound for B, and it marks a lower bound for A. So which of the two is it? How do we know if the y value of f of 1.1 is greater than or less than 6.2? Because that will give us the answer to A or B. So to figure this out, we need to realize that the gradient of the gradient function, or in other words, the concavity, is decreasing. This function here is decreasing at x equals 1. So what that means for the original graph is its gradient is increasing, but at a decreasing rate. At a decreasing rate. So that means we have something that is suggesting that we have a stationary point and x equals 1 is somewhere here, right? So we have this point, we have the gradient of the tangent being y equals 2x plus 4, and we've just concluded that at x equals 1.1, which I'm going to do in blue here, let's say this was 1.1, this y value is equal to 6.2 at 1.1. And what we can see by, I guess, sketching this out is that 6.2, the y value there, is larger than the actual y value on the curve. So the value of f of 1.1 should be less than 6.2. And that suggests that B is the answer. Question 10 says the graph of y equals f of x with all its stationary points is shown, and it shows us that graph. How many stationary points does the graph of y equals f of e to the x have? Now, to work this question out, we need to realize that, well, stationary points occur when the gradient function is equal to 0. And the gradient function of this, well, if we actually just derive this, dy dx, we get e to the x times f dash of e to the x. And that's just using chain rule. And the stationary points occur when dy dx equals 0, when that gradient function is equal to 0. So 0 equals e to the x times f dash e to the x. And that means e to the x is equal to 0, or f dash e to the x is equal to 0. We should know that the graph of e to the x is always greater than 0, and strictly greater than 0, I should say, because it's always falling in this top half of of the graph. So that means this solution here doesn't exist, okay? Can't exist because e to the x is never 0, so this isn't a stationary point. So that means the stationary points only occur when f dash of e to the x is equal to 0. Now, this here is essentially the derivative function of f of e to the x. And what we need to realize is that the stationary points of this chart are going to be equal to the stationary points of f of x. Okay? So we have a stationary point at f of x here. So let's call this minus 0.5. We have one here at 1, and we have one here at, let's say, 2.1. So that means for this solution here, if we substitute e to the power of x for just x, well, we have our stationary points at x equals minus 0.5, at 1, and at 2.1. But we know that, it's not actually x, it's actually this e of x that we have replaced. So it's when e of x is equal to minus 0.5, when it's equal to 1, or when it's equal to 2.1. And we need to realize yet again, by the function that is e to the power of x, it can never be less than or equal to 0. It's strictly greater than 0, which means negative 0.5 is not a solution to that equation and only leaves us with 1 and 2.1, i.e. 2 stationary points. So our answer is C.